First lecture of Chapter 15 is going to include solubility, solution composition and introduction, and solution composition and mass percent. We'll start with solubility. So what is a solution? It's not an answer to a problem like you would answer in math class, but a solution is considered a homogeneous mixture. Remember, homo means the same throughout, so a homogeneous mixture. It is made up of a solvent, which is the substance that's in the largest amount in the solution, and solutes, the other substances in that solution. An aqueous solution is a solution with water as the solvent. Water is known as the universal solvent, by the way. So most every solution that we're going to talk about is going to have water as its solvent. Here are some other types of solutions that maybe you don't give a whole lot of thought to. You can have a solution of gas where the solvent is a gas, the solute is a gas, and the state of the solution is a gas. So we don't think about that very often, but that's what we can have solutions in gaseous form. We also have solutions in liquid form, which we're familiar with. Probably the most common one that we'll discuss or bring up as an example in class would be making tea stronger or weaker, or Kool-Aid stronger or weaker when we talk about how much solute we have in it. Brass is an example of a solid solvent. So we have two solids going together to make brass, which we covered in the last chapter. One that maybe is a little different is carbonated water. We have liquid as the solvent because it's the most abundant in the solution, and gas would be the solute. Seawater, sugar solution, where the liquid is solvent, but then there again the solute is a solid that's dissolved into it so that you have a liquid solution. Solubility of ionic substances. Ionic substances break up into individual cations and anions when you put them in water. So there's sodium chloride, we put it in water. It's going to break up into sodium ions and chloride ions to make salt water. Polar water molecules interact with the positive and negative ions, and they get surrounded by water, and that's why it dissolves. Ethanol is soluble in water because it has a polar OH bond. So we found out in the last chapter that this unequal sharing of electrons causes a slightly negative and slightly positive end, and water is going to be attracted to that because water is very polar, has a slightly negative and slightly positive ends as well. So why is solid sugar soluble in water? Well, if you notice, look at what happens out here on the edges of sugar. We see an OH, an OH, an OH, OH. All of these OHs that are going to have an unequal sharing of electrons are going to be attracted to water molecules. The water molecules are going to surround it, and it's going to be soluble in water. So what happens when we have substances that are insoluble? What makes them insoluble in water, such as oil in water? Oil is nonpolar. It doesn't interact with polar molecules, so if it's not like, it's not going to mix. So we have a nonpolar oil and a polar area of water. You can stir them up, you can mix them up, and they're going to separate again. Water-water hydrogen bonds keep the water from mixing with the nonpolar molecules because the water molecules are more attracted to themselves than they are to something that doesn't have much of a polar attraction. So in order for a substance to dissolve, a hole must be made in the water structure for each solute particle. And the lost water-water interaction must be replaced by a water-solute interaction. Otherwise, water is just going to be attracted to itself. Remember that like dissolves like, and that will help you answer some of the questions that are coming up. So which of the following solutes would generally not dissolve in the specified solvent? Choose the best answer. Assume all the compounds are in the liquid state. Remember also that like dissolves like. So let's just look and see what's polar and what's not. So we start by looking at the CCl4 and water. Well, we know that water is polar. Let's just put a P here for polar. CCl4 is a compound that looks like this. There is a tetrahedral arrangement. It's equal pull on that carbon. So this one is probably a nonpolar molecule. Remember that like dissolves like. So this one probably is not going to dissolve very well. If you look at the next one, we have NH3 and water. Remember again, water is polar. NH3, is it polar or not? Well, it has a formula. If we have 5 valence electrons in nitrogen, plus we have the 3 from the hydrogen, so it's a total of 8. So we do this, we put the hydrogens out here like so, and we have our extra pair here. So we have a pair of unshared electrons here making it polar. So it's polar, and is it going to mix with the polar substance? Like dissolves like, so that's probably going to mix well. Here we have polar again. This automatically we know is polar. It's an alcohol. It has an OH molecule on it, so it's going to show polarity. It's probably going to mix with the water. We look at CH4. CH4 is set up like CCl4, where we have a carbon as a central atom with 4 hydrogen coming off of it. So this tends to be nonpolar. And N2 is, of course, diatomic, and it's going to be bonded together with another N, and it's nonpolar. So remember that like dissolves like. So this one should mix. These two should mix. These two should mix. We come up here to this one. We're probably not going to see this happen because water is so polar and the carbon tetrachloride is nonpolar. Let's check our answer. The one that is generally not going to dissolve is CCl4 in water. Let's look at 15.2. The solubility of a solute is limited. Saturated solution is a solution that has as much solute as will dissolve at that temperature. An unsaturated solution has not reached the limit. So if it's unsaturated, you could put more solution or solute in the solution and it should dissolve. Saturated means it's topped out, it can't take anymore. There's a supersaturated solution, and this occurs when we take a solution that is saturated at an elevated temperature and then we cool it, but all the solid remains dissolved. So if you're making tea, for example, and you make the tea hot and you put sugar into the tea, you can dissolve quite a bit, and when you cool it back down, it's going to stay dissolved in the solution. However, if you have iced tea and you want to put the same amount of sugar into it at a colder temperature, it doesn't allow it to dissolve. So a supersaturated solution occurs when we elevate that level, put the solute in it, allow it to cool, and the solid remains dissolved. It contains more dissolved solid than a saturated solution at that temperature. It is unstable though. Adding a crystal causes precipitation, so you can actually cause it to fall out of solution and precipitate out. Solutions, remember, are mixtures. The amounts of substances can vary in different solutions, so we have to specify the amount of solvent and solute. So what that's saying is if we're going to make Kool-Aid and you're going to make a packet of Kool-Aid in a 2-liter container and I'm going to make it in a 1-liter container, they're both solutions, but they're mixtures, and mine is different than yours. Qualitative measures of concentration are what we're going to look at with this chapter. So concentrated means relatively large amounts of solute. Dilute means relatively small amounts of solute. So you think of, let's go back to Kool-Aid again. I make the one that's a package of Kool-Aid, and I put everything in a 1-quart jar, and you make it and you put 1 packet of Kool-Aid in 1 gallon. The 1 quart is, and we'll say 1 packet, the 1 quart is much more concentrated than the 1 gallon. This one, if you think about trying to drink it, you only have a cup of sugar in there with it, so this one's going to be very bland, not flavorful, doesn't have the sugar level like you like it, so it's dilute. If we put that in a quart jar instead of a 2-liter container like it's normal, it's very concentrated, very sweet, and a lot of flavor. Let's look at some examples of how to calculate mass percent of a solution. This is really no different than when we talk about how to figure your grade on a test, because we're going to take, if you're going to find the percent that you made on a test, you take the total number from the test, however many you have out of that test, take what you scored divided by the total times 100, and that gives you your percentage on that test. Well, when we talk about a solution, we're going to use mass percent. So to find mass percent, we can take the mass of the solution, and remember the solution is the solute plus the solvent. So let's write that down here so we have it. This is the solute plus solvent, but the mass of those. And we're going to take the mass of the solute alone, divide it by the mass of the solution, and multiply times 100. The way you can look at that also, we take the grams of the solute plus the grams of the solvent, that's your total mass. Take the grams of the solute and you divide that by your total times 100, and that gets you the mass percent. Let's look at this problem. It says, what is the percent by mass concentration of glucose in a solution made by dissolving 5.5 grams of glucose, and 78.2 grams of water. So remember that our mass percent is going to equal the mass of the solute divided by the mass of the solute, or I could say just mass of the solution. Back that up and do that. Mass of the solution. And remember that the solution is the solvent plus the solute. So we're going to take the mass of the solute, which in this case is going to be the glucose, so 5.5 grams. And we're going to divide that by the mass of the solution, which is going to be the solvent, which is 78.2 grams, plus 5.5 grams. And then we're going to take that answer and multiply it by 100. And when we put that in the calculator, we get 6.57%, which is the percent by mass of the glucose in the solution. Now, I know that this is just a baby step that you need to watch out for, but you're used to doing higher level math, so sometimes we forget the basics. Just remember when you put this in your calculator that if you're going to put it in like this, that you put 5.5 divided by, and then make sure you put your parentheses, because otherwise your calculator is going to take 5.5 divided by 78.2 and take that answer and then add 5.5 to it, and that's not what you want it to do. So just make sure that you pay attention to following the order of operations when it comes to the simpler problems.